Shorten, good evening.
Good evening, Gustavo. Good morning for you. It's 7 p.m. here.
Yep. Good evening for everyone in the Middle East.
Hello, Gustavo. Good morning.
Okay, so Shorten, I don't know if you want to start or do you want to have a few words before we start?
Yes. We would like to welcome you, welcome everyone. We have Symbios team with us. We have the senior consultants. We have WA Solutions team. We have Vincent as well. So we have so many experts in this room and great candidates. I see you have big number of people and highly qualified people, supply chain passionate people. So it's a great opportunity for us to play the game with you tonight. Okay, so Gustavo, you can lead.
Okay, thank you very much. Well, good evening, everyone. It's a pleasure to welcome all our Symbios-Consulting guests today for the WA DDMRP distribution simulation game. So it's a game. We're here to have fun, but we're also here to learn this innovative DDMRP model. So we'll make an analogy. We'll say like the supply chain is like a living organism. So the supply chain, we breathe demand, we consume inventory, but the supply chain can also get sick. Like us, we can get the flu. The supply chain can also get sick because of the volatility of the demand. There is high variability of demand, high variability of supply, and that can make the supply chain not have the results we're expecting. So let's think about demand-driven as our immune system. Demand-driven will help us because instead of guessing the future demand, it will place dynamic buffers exactly where they are needed to protect the flow and to generate profits for your company. So in the next 2 hours, you will run a virtual distribution network, feel the pressure of real demand, and feel the pressure of having changes in that demand, and discover how quickly a buffer can turn chaos into clarity. So this will be very, very exciting. So in the first round of the game, you'll be managing your inventory the traditional way, the way you use it. You will use forecasts to plan your purchases and to generate your manufacturing orders. But then there will be variability. So expect some stockouts and also expect some excess of inventory. And also sometimes your supply chain will be unstable. For round 2, we'll do a demand-driven shift. We'll start using the DDMRP model. We introduce the strategic decoupling points and the color-coded buffer signals. Watch the lead times improve your service level, and obviously hit your profit bottom line in seconds. So you'll see how the results improve. So your mission in this game, it's keep your customers smiling. It's very nice to have happy customers because they buy from us. They give us profits. Besides keeping your customers smiling, you will have to protect cash because inventory is money. So too much inventory or too little inventory both hurt our business results. So we'll try to have a balanced inventory, and then we'll do some collaboration between the planners, the buyers, the salesmen. We need to synchronize the supply chain like never before, and the system will provide great results. We will take a look at the financial results after the first round and the second round and see a huge difference. So I think it's time to start having fun. Let's the simulation begin. I'm going to handle the controls to to Ricky, and Ricardo will show how the game is played, what the rules are, so you are ready for playing. Ricardo, please.
Okay, thank you very much, Gustavo, and thank you for the introduction of the game. Before we get started, I would like to share with you guys my screen, but also to send you a message so that you can start logging to the application. Just give me 1 second.
Showing the rules of the game.
Yes, Gus, please.
Okay.
I'm trying to share my screen.
Okay.
Okay, I think that I'm now sharing my screen. Okay.
Okay. Go ahead.
Okay. So I'm having some issues with the computer. It doesn't allow me to change or switch from. Oh, could you start, Gustavo, until I?
Yes, I will. All right. So we'll start explaining the rules about the distribution game. The objectives of the game, as I said before, you have to guarantee service level to your customers. You also have to guarantee inventory rotation, so you can keep the inventory in the right level. And you will guarantee the synchronization of the supply chain. So let's keep in mind these three objectives, and we will follow up with this after the game. So this is the network that we will be using for our game. We have a raw materials team that will buy products or raw material from the suppliers. The lead time for the raw materials are 5 days, and the MOQ will be 100 units. It's only one product that we'll be using during the simulation. So the raw materials warehouse will start with an initial inventory of 200 units. Then we'll have some people working in the plant. Some of the participants will do this role. And you have a number of workers. At the beginning, we'll start with 13 workers that will produce a finished product for the central warehouse. The lead time is 5 days for the finished product, and the MOQ is 100 units. So the minimum quantity you can manufacture is 100 units. You can manufacture 100, 101, 2, 3. So it has to be above 100. Then we have the central warehouse. The central warehouse will start with an initial inventory of 200 units. The central warehouse has to deliver product to our distribution centers. You can see the lead times and the minimum order quantity for each distribution center. As you can see, the MOQ is the same for everyone, but the lead times can change. For Atlanta, the lead time is 5 days. For Boston, the lead time is 4 days. For Chicago, 3 days. For Dallas, 2 days. And for Los Angeles, 5 days. Each of the distribution warehouse has one salesman that is going to be selling the product to the customer. The central warehouse also attend 4 salesmen that they sell direct sales from the warehouse. So they not only deliver product to the distribution centers, they also have to deliver product to their 4 salesmen that will be selling product in their city. So in total, you have nine salesmen. We're going to use the forecast as we always do when we're planning. We're using like a dice to do the forecast. So a salesman during the 5-day week from Monday to Friday, they can sell a minimum of 1 product or a maximum of 6 daily. So weekly, it can sell from 5 units to 30 units. 30 is the maximum the salesman can sell. The central warehouse, we also said that we had 4 salesmen. So it's like throwing 4 dice. Well, what's the minimum they can sell? 4, if they all have 1. And the maximum, 24, if all of them have a 6, like here. That's daily. And weekly, we will have 20 minimum and 120 maximum. Okay. So in total, we have 9 salesmen. The minimum we can sell is 9. Obviously, it's a very low percentage that we get 9 ones at the same time, but that's the minimum. And the maximum is 54. That's if we get 9 6s in the dice. Weekly, we will have a minimum of 45 and maximum of 270. So that's the forecast you have for the month. The plant also is going to use dice. Each worker is 1 dice. So the minimum the worker can manufacture is 1. The maximum will be 6. So weekly, we will have minimum of 5, maximum of 30 units produced by each worker. So we said we are going to start the game with 13 workers. So the minimum they can manufacture is 13. The maximum it can manufacture is 78 daily. Weekly, 65 minimum, 390 maximum. So during the game, you can hire more people or you can fire people. You can adjust your capacity, hiring or firing people. As you can see, at the beginning, the maximum production exceeds the maximum demand. So you should not have any capacity problems at the beginning. So we're going to take a look at the game rules. We order weekly, every 5 days. So we don't order every day. We have to order once a week. If the regions do not have enough inventory to supply the day sale, it's recorded as a lost sale, which is not recoverable and has a penalty. What does that mean? That we don't allow back orders. If you don't have the product, you are going to lose the sale. And it will impact your financial results. So watch out not having stockouts. The nodes cannot communicate directly with each other. It means that the nodes cannot send product one to another. It has to be through the central warehouse. And the H node only knows what it costs to customer request. They don't know the demand of anyone else. If the plant can't produce more than what the central warehouse requests, this production is lost. So it will be lost capacity. See? So if you don't have enough production, your workers will sit idle and will lose money. Unfulfilled orders are canceled. So there are no back order. We just mentioned that. Conditions and costs. Minimum transfer order to regions, 10 units. We talked about the MOQ, transportation MOQ, 10 units. And the freight is $10 per order. Minimum order to the plant is 100 units, and the freight is $10 per order. Minimum order quantity to the supplier, 100 units, and the freight cost is also $10. The price of each unit to the customer is 10 units, $10 per unit, and the cost is $6 per unit. So there's a margin of $5 per unit sold. Inventory carrying cost is $0.1 per unit per day. So that's the inventory carrying costs. Labor cost $2 per day. So it's $100, $10 a week, I mean. And the penalty of lost sales is $5 per unit. Don't worry much about the numbers. So we just wanted to let you know that every decision costs. If you do a good decision, you will have profits. If you do a bad decision, you will have a lot of inventory. It will cost you, or you will have stockouts and it will also cost you. But that calculations will be done by the system. So let's play. Ricardo, have you solved your problem?
Yes. Yes, I have.
Excellent.
Okay. Can you tell me if you can see my screen now?
Yes, we can.
Okay, perfect. So as Gustavo mentioned before, it's an easy game. So what are we going to do? We're going to plan only one product. Okay. Our supply chain is only one product company. Okay. So what are we going to do now? In the chat, I sent you the a small invitation, so you can log in to the website. Just for example, in this image, you can see the that we have the link already. You can set up the link. You can log into to the game, and also you can change the language. Maybe you want to learn a little bit of Spanish. You can change Spanish, but I think you will prefer the English version, right? Okay. So once you are logging into the web page, you're gonna have this screen. As you can see in my screen, you're gonna be requested by adding your email, your name, the company, and a specific code that I'm gonna be sharing to you. Okay. In the chat, you have the code of the game. Okay. So don't worry about the game. I know that maybe it's a little bit confusing at the beginning, but since you are playing the game, everything's gonna be easy. Okay. So what are we gonna do now? We're gonna assign the participants. Okay. But it is important to mention something. As Gustavo said, we have 8 different areas. We have the raw material, we have the plant, we have the central warehouse, and we have also 5 distribution networks. So we have 8 different areas in my supply chain network. Okay, so it is really important once you are assigned to one specific network, you need to add in your name the place where you were assigned. For example, right now we're going to assign you guys to the different areas. So if you are assigned to the plant, I hope that you write in your name the first, the area that you were located, for example, the plant, and then your name. Okay. For example, if I'm in the raw material, I need to write RM or raw material. Don't worry about it. And then your name. Okay, so be sure that you have these configurations so it will be easier for us to identify you guys. Okay, so in the company as well, or maybe in the email if you wanna switch the name as well, maybe you can add in the mail the location and then your email. That could also work. Okay, so what we're gonna do now, we're gonna split you guys into different areas in the supply chain. I'm gonna share only the distribution network if you have any question. Okay. So since we are 50 people, I don't know, Zainab, are you in the session? Can you help me to
Yes.
to assign the people randomly into the different rooms? Maybe we can name each people and tell them in which location they are. For example,
Will be assigned automatically, but randomly, and some people will stay in the main room with you.
okay, yes, but it's important to let them know in which room they will be assigned. If you assign them randomly,
Yes,
okay.
each room has a name.
Okay, perfect.
So you need to start it now?
Yes, please.
Okay.
So let me. Can you call them back, please? I thought that you that we were we're not supposed to open the rooms already. What are we gonna do now? It's to call them back to the main room, please, and explain them how they're gonna interact. Okay.
Okay, they are back now.
Okay, perfect. So it's important then to know in which room they are. Okay. For example, I was hoping that you read the name and tell, for example, Amira, you are in the main room. Iman, you are in the main room. Kamel, you are in the plant, and so on. Okay. So they understand what's going on. I will do the setup of the game with them, but they need first to know where they are located. Okay.
Perfect. We went into the room, okay? It's important to check who is going to what room, okay?
Yes, exactly. So, for example, Zainab, can you tell us in which room they are assigned? Do you have the list on each room?
I have the list for each room, yes.
Okay, can you help me with the names, please? For example, we start with the raw materials. Who are in the raw materials?
Yahya?
Yahya, Ahmed,
Yes.
Yahya?
Yes.
Well,
Adnan, Muhammad Abdurrahman, and Mr. Gustavo.
perfect. Okay, so you guys are gonna help me out with the raw material. Okay, so if you have any question, Gustavo is gonna lead you in the raw material. If you have any doubts about the MOQ, about the lead time, about the units. Okay, who are in the plant?
In the plant, we have Ibrahim Saftawi, Mirihan Ahmed, Jason, Juan, Vincent, Tani, and Muhammad Awad.
Okay, perfect. So for example, in the plant, Vincent, if you have any doubt, Vincent is gonna lead you in the plant. Okay, so Vincent is gonna be in charge to help you out with it. Okay. Who else is in the central warehouse?
Abdullah Sanat, Ahmad Tilip, Muhammad Qazmi, Yuan, Alex Mu'taz.
Okay, perfect. So Juan Camilo is gonna be leading the central warehouse. If you have any question, Juan Camilo is gonna be in the room with you guys in the central warehouse. Okay. Okay, who is in Atlanta?
We have Ayman and
Ayman.
Shireen, Mahmoud Yusri, Hussam, Muhammad Salah, Ahmed Abu Yazid.
Okay, perfect. Okay, guys, no one's gonna be in Atlanta. Okay, so I hope you to know, for example, the main constraints that we have in Atlanta. For example, as Gustavo mentioned before, you will start with 20 units of inventory, okay? And remember that you have a 5-day lead time and an MOQ. And the only thing that you're going to do, I'm going to explain it in a few minutes, it's to set up an order, okay? You're going to release orders to the central warehouse, okay? So that you can accomplish these 3 main objectives: guarantee service level, guarantee inventory rotation, and guarantee the synchronization of only one product, okay? Who else is going to be in Boston?
We have Mario, Fahd, Difallah, Ayman, Saber.
Perfect. You guys, as well as Atlanta, you are going to start with 20 units of inventory, and you have the same 3 objectives as we mentioned before. And I will explain where to locate the orders. It's really easy, okay? But first, I need you guys to log in into the web page, okay? Who are in Chicago?
عبد الناصر and جمال.
Okay, perfect. Who are in Dallas?
عمرو محمد السيد، مصطفى حسنين، أدهم، محمد غنيم، إبراهيم عبد الله، عبد الرحمن.
Okay, perfect. And Los Angeles? Who will be in the main room will be for Los Angeles, okay?
Yes. ممكن.
Okay, guys. I see that you now are logged into a session. For example, I see that Vincent has already joined, Gustavo, Samir, Yakia, Ayman, Tani, Ayman, okay. The other participants could log into the game. I have Juan David also in the game. Okay. Okay. Remember, guys, that the name when you are located into the game, you needed to first mention where you were located. Okay. For example, raw material. Okay. But don't worry about this. Okay. Maybe we can do the game with this allocation. Just I'm gonna change Gustavo to the raw material, and Vincent, I'm gonna change you to the plant. And Zainab, can you help me with this new red distribution? For example, Mohammed. Let me see if I can. Okay. Maybe we can. Yes.
Now we have Muhammad Abu Zaid in raw material.
In raw material, yes. Okay.
Yahya is not in Atlanta and a warehouse now. Atlanta, okay. Yes.
In central warehouse, we have Samir. Can we change Samir to the central warehouse?
Yeah, he's in the central warehouse, isn't it?
Okay. Atlanta, can we change Yahya to Atlanta? Okay. Can we change Yahya? We have Ayman in Boston. Ayman Bafarah.
Yeah.
And Ayman Saber in Chicago.
Ayman Saber is in Boston.
Okay, Boston. Let me see. Okay, here I have Ayman and Adan.
No, the another Ayman Saber. The third one. It should be in Boston or in what?
Okay, I'm going to change it. Him, Ayman Saber in Boston, and Ayman Bafarah in which place should be located?
In the main stage, Los Angeles.
Los Angeles. Okay, let me change him to Los Angeles. Okay. Let me see. In Chicago. Okay, Chicago is already allocated. Dallas. Dallas, we have Tane. Quetzal.
Do we have anyone who has been able to connect? Who hasn't been able to connect?
Tani is in the plant, the one in Chicago.
Tani is in the plant.
In the plant, yes.
Let me change to the plant. Okay. Who should be in Dallas?
In Dallas.
I have Gina.
Gina.
Let me check.
4 عامر محمد.
Maybe we can.
We have عمرو.
عامر محمد. مصطفى حسنين.
عمرو محمد. I don't see his name here.
Yeah.
We also have in Los Angeles.
Yeah.
Ayman and David.
Mario Enrique Lopez is asking to be assigned to Boston.
Okay. Lopez.
Yeah.
Which one is it?
Mario Lopez. You'll see Mario Lopez. Yes, that one.
He should be where, Gustavo?
He said he should be in Boston.
Okay, Boston. Let me change him to Boston. There you go.
And Yahya should be in raw material, but
okay.
But he's assigned to Atlanta.
Let me change him to the raw material. There you go.
Okay.
Who else must be assigned? We have Juan David and Ayman at Los Angeles. I don't know if this one is correct. I have Falah in Dallas. Is that correct, Zainab?
I can see him here.
Okay, don't worry. I will assign it to Dallas. Is there anyone else that it's not correctly located into the?
Yeah, sorry, Dayfallah is in Boston.
Which one?
The last.
Dayfallah. This one should be in Boston.
Yes.
Okay.
Yes.
With Mario Lopez and Adnan. Adnan Ahmed.
Atlantic.
Mario.
Anas Sharaf. Guest.
Mario Boston.
Mario's in Boston.
Mario is in Boston. Perfect. There you go. I think someone raised a hand.
Yeah.
Do you want me?
Can we do a quick review? So in raw material we have Mohamed, Gustavo.
Mohamed Al-Bosaid should be in Atlanta. It says what Mohamed said that.
Okay, I'm going to change him to Atlanta.
We have Mini Muhammad, so Muhammad Abdurrahman is in raw material. This one. Yes, the one you moved with now.
Okay. Mohamed.
No. Yes, the second one.
That
the second one. No.
Second
one.
The second one, yes. Yes,
should be
in raw material. Yes.
Okay, there you go. Vincent, it's going to be in the plant with Tani. Central warehouse, we have Ahmed, Samir. Okay, in Atlanta, we have Mohamed and Ayman. In Boston, we have Mario Lopez, Dayfallah, and Adnan. Okay. Chicago, we have this one, Chicago and Mohammed. Then Dallas, I have Ahmed and Gina, Juan David, and Ayman at Los Angeles. Is that correct?
Yes, correct.
Okay. I'm gonna start the match. Yeah, don't worry, guys. If you all are not located into a game, since someone of your team is in the game, when you enter to the break rooms, he can, or that person can share the screen with you. Okay. So I'm gonna start the match. So, quick important rules, guys. I'm gonna activate the orders. Remember, this is a simulation. We're gonna simulate many days. Okay. So we're going to start in day number 0. Okay. It is important to place an order. Okay. So you're going to have this box like here. It's an empty box in which you can send an order. Okay. For example, I am in the raw material. I am Gustavo Benitez. And I say, okay, I think I made my calculations. And in order to accomplish the 3 main objectives, that was guarantee the service level of the company, guarantee inventory rotation, and guarantee the synchronization of the supply chain, I think I need 90. So I send 90, but I have an important rule. Remember that my MOQ was 100, so I cannot place less than 100. Okay, so for example, if I want to place 100, I just send 100 and it gets corrected. Okay, if I don't want to send any order, I just send 0, and you can see there is no order replaced. Okay, if I want to send 101, you can do it. You can do as much as you want. Okay, for example, I commit a mistake. I want 200. Just type 200, and it's gonna be fixed. Okay. It's going to be the same for everyone except for the plant. The first 5 days in the plant, you guys need to understand what's going on with the supply chain. Okay, you're not managing people. Remember that the plant, you're going to manage people. You are like human resources. You're going to determine either you need more people or less people. If you're going to hire more people, you're going to do it in day number 5. In the first 5 days, you're not doing anything. You just analyze the supply chain and determine whether you need more or less employees. Okay. Central warehouse, you also have your box over here. The only thing that you need to do is to analyze. You had a forecast. Remember that it is important to mention you had one forecast, and your forecast said that you have a minimum sales of 45 per week and a maximum of 270. And since you are starting with 200 units, I think that it's a good call for you to place an order. Okay. So you need to place something here, right? So for Atlanta, Boston, Chicago, Dallas, and Los Angeles, you need to place orders. It is easier for you since you have only one salesman. So your maximum forecast, remember, for the distribution network, before we get started, remember this is your forecast. Yes. In 1 week, you can sell 5 units or 30 units. This is your minimum and this is your maximum. And you are beginning with 20 units of inventory. So I think that it's important for you guys to set an initial order and send it here. Okay. So I think we're ready. I wish you luck, guys. Remember, we're simulating the first 5 days right now, and then we're continuing with the other days. Okay. So can you help me, Zainab, to open the break rooms, to send them to the rooms? And if anyone has any question, we will discuss in the following 5 minutes. Okay. So good luck, guys. So the ones that are in the main room that haven't been assigned.
Yes, can't be assigned.
Okay, you guys are gonna be with me in Atlanta. Okay.
And in
So
Los Angeles.
Sorry, at Los Angeles. Okay.
Yes.
So for example, I am here right now at Los Angeles. So what it is important here, guys? Here I have Juan David Jimenez and Ayman. Okay. So you guys need to discuss and analyze. Okay, I'm starting with 20 units of inventory. Okay, I only have one salesman. He can sell whatever he would like. If he throw a dice, the minimum is 1 and the maximum is 6. Okay, that's my forecast. Weekly, I can sell 30, but I have 20. I know that my lead time is 5 days. So if I place an order right now, the inventory will arrive in the day number 5. So what do you think, guys? Do we need more inventory? How much do we need to place in order to keep in track with this game? Remember, we need to accomplish 3 main objectives: service level, inventory rotation, and last but not least, the synchronization of the supply chain. I think, Zainab, they are not allowed to open the mic.
We can
allow them if anyone want to talk, they can raise their hand and we will unmute him.
Yes. Ahmed has a question.
Okay, hello. Ricardo, if you can hear me, I believe we should wait for the demand signal, for the first demand signal, upon which we can determine our stock level.
No, in this case, for example, you don't have demand. You are blind, okay? You don't see anything. See, this is the first time you see this product in your life, but you had a forecast, okay? What's the minimum and maximum that you can sell daily? Remember?
I believe it's 54, the maximum.
Okay. Let me show you my screen now. This is your forecast. Since you have only one salesman, this is the forecast, okay? Minimum, okay. You're gonna throw a dice. And the minimum that you can sell is 1. And the maximum is 6. Okay? But yes, my planning process is weekly. And my week has 5 days, okay? So the minimum I can sell is 5. And the maximum is 30. What are you gonna do?
So I will go for having 30 in my stock.
Okay, so maybe you can set up here the order. If you are not in the game, don't worry, I can set it for you. But if you are in the game, just click the amount and send it. Okay?
I am in, and I will send it.
Okay, I now can see the 30 units of inventory. Okay, it is easy right now. You are in Los Angeles, you send the order. It's really easy, right? What are we gonna do now? I'm gonna deactivate the orders and we're gonna see day by day up to the day number 5 and see what happened. And in the day number 5, you can restart the orders, okay? Was that clear?
So I can't place my order now. I must wait for day 5?
Yes, exactly. And in the day number 5, we reopen the orders and you can set a new order. Okay. But that order is going to be for the day number 5. Okay. Not for the day number 0. We are in the day number 0 right now. Okay. I don't know if the other participant has any doubt, any question. If there is no more questions, we can call them back to the main room. Zainab, can you help me calling them all back?
Okay.
This is gonna be the dynamic scenario. We're opening, closing, opening, closing. It's gonna be fun.
Whoa, we haven't finished.
Okay, Juan, you were in the central warehouse, but
yes,
I saw that there was an amount in the central warehouse. Do you want to go back to the discussion? I thought that you have already set up an order.
Yes, the team set an order. Yes.
Okay. Can we start with this order, or you wanted more time?
I don't know how's the people doing. They have made an order already.
Can you raise a hand if you already set an order? Okay, Ayman says.
Hello.
I think they did. Okay.
I came back to the raw material. I don't know why shifting to here again.
For example, in raw material, you set an order of 200.
I was there.
Yes.
I don't know how it's shifting here.
Okay. In which place you are set up?
Raw material.
Raw material. You are Mohammed?
Anas.
Amas?
Yes.
You're supposed to be in the raw material, but
yes,
you are.
I was there. Then suddenly shifting to here.
Okay. So in which place you are?
Because
right
we
now?
stopped the breakout rooms, so we come back. We come back again.
Okay.
Yes. Don't worry. Okay. So,
okay.
I need Atlanta. Who are supposed to plan Atlanta? Ayman, Mohammed. Do you require more inventory, or are you gonna stay with 0 units of inventory? Ayman, Saber, and
you need to make an order.
Yes. Are you okay with 0? Or can I just help you with?
Ayman is raising her hand. Ayman Farah.
I give them.
They
have access to talk. Please, Ayman, Mr. Ayman, unmute yourself.
Samir Ali is also raising the hand.
Samir, Abdullah, and Ayman. They have access to unmute themselves.
Yes. I just joined with the team, and the team not hearing me. I am already making an order, but I don't want. I need to know. And everyone is already take a decision himself, or the team should agree on a decision like ordering and.
No, the team has to agree to a quantity. Only one quantity per team.
Yes. Well,
so
what quantity?
Okay, because I think I need the technical support, because the team are not hearing me. They already spoke to each other, but I am not engaged in the discussion.
Okay, so they couldn't listen at you. Okay. In this case, for example, we need to set an order for Atlanta. Not to be in 0, okay? Because being in 0 will be painful. Okay, maybe yes. we can set a standard order. What do you think? Maybe 15 units could work, and then we simulate.
Why don't you let them pick the number? Maybe they want 0.
Okay, do you want 0? Okay, they want 15. They set an order of 15. Okay, so this is the dynamic, guys. Every 5 days we're gonna send new orders, and we're gonna simulate what happened in the supply chain. Okay, so now I'm deactivating the orders, so now you cannot change the orders that you set up, for example, and we're gonna start the simulation with the raw material. In this part starts the fun part. Okay, for example, we're in day number 0. Raw material, we have Jackia, Mohammed, and Gustavo. They said, okay, I need 200 units of inventory. Why? Because those 200 units will help me to accomplish these 3 main objectives. But what happened day number 1? Okay, the supplier said, okay, I don't have 200 units of inventory. I can only deliver 160 units. I'm gonna ask you something, guys. Does this can happen in the real world? Does the supplier always supplies what we suggest or what we order? No, this never happens, okay? Sometimes could happen, but also sometimes could not, okay? So that's really important to mention, right? So what happened next? For example, in day number 0, you started with 200 units, but the supplier could only ship 160. So in the day number 1, you are expecting for 160. What happened with the plant? Since you are delivering material to the plant, remember, this is a chain, okay? The raw material gives material to the plant and the plant manufactures it. The plant started with 13 employees. These 13 employees throw a dice, and the amount of the dice was 49 units. So in day number 1, they're gonna produce 49. So they require 49 units of your inventory, okay? So that's the reason why in day number 1, you end up with 151 units of inventory, and you are waiting for 160 units to be delivered in the day number 5, okay? What happened with the plant? The central warehouse set up an order of 200 units. Remember, if the plant can produce 200, the plant will deliver 200, okay? If the plant cannot produce 200, the plant only deliver what the plant can produce. If the plant has more capacity, the plant only deliver what the central warehouse suggests, okay? In this case, you have an order of 100 units, sorry. And you start with 200 units of material. That means that you can deliver that amount, okay? In day number 1, you started with 13 employees. You threw the dice. The dice said you can manufacture 49. So your stock now is 151, and your cumulative production is 49. You're gonna stop the production when you achieve the 100. Why the 100? Because that was the amount that the central warehouse
asked for.
Yes. Let me see the central warehouse. What happened with the central warehouse? Okay, in the day number 0, Atlanta, Boston, Chicago, Dallas, and Los Angeles set orders, okay? Atlanta need 15, Boston 10, Chicago 10, Dallas 12, and Los Angeles 20. If I add all these demand, I'm gonna get 67, okay? That's the amount of the order that I shipped in day number 0, okay? So you started with 200 units of inventory, but you ended up with 133 units of inventory because you needed to ship 67 units in day number 0, okay? That means that you remain with 133 for your daily sales. In day number 1, your 4 salesmen, remember that you have 4 salespeople, threw the dice, and the amount was 12. So that means that you ended up in day number 1 with 121 units of inventory. What happened with Atlanta? Atlanta in day number 1, your salesman was too poor. They only sold 1 unit. That means that you remain with 19 units in day number 1. And you're expecting to have 15 more units in the day number 5. Remember, this is your in-transit inventory, and Atlanta has a 5-day lead time, okay? What happened with Boston? Okay, Boston, you're in day number 1. You sold 3 units. You started with 20 units. Now you sold 3. You remain with 17 units of inventory, and you're expecting these 10 units to arrive in the day number 4. Why in day number 4? Because you have a 4-day lead time, okay? Chicago, you sold 4 units, and you're expecting these 10 units to arrive in day number 3. So that means that you remain with 16 units in day number 1, okay? Dallas, you sold 3 units, and you remain with 17 units in day number 1. You're expecting 12 to arrive by tomorrow. Los Angeles, you sold 2 units, and that means that you ended up day number 1 with 18 units, and you're expecting 20 units to arrive in day number 5. Okay, let's move on with the simulation. What happened in day number 2? Let's see. In day number 2, the plant threw the dices, but now the plant could only manufacture 42. So that means that you remain with 109 units of inventory. But what happened with the plant? Guys, in this case, Vincent, Abdallah, Tani, you need to be worried about something. The order is only 100. You are almost there. In day number 2, your production is 91. You need to deliver 100. Okay, so that means that with the 13 people, you have excess of capacity. You need to think about that in day number 5 because you don't want to have lost capacity. If we have lost capacity, we have the people doing nothing, and that is expensive, right? So in this case, you ended up with a raw material inventory of 109, but your cumulative production up to the day number 2 is 91, and you need to achieve the 100 that the central warehouse asked for. The central warehouse. Today, your salesman sold more than yesterday. You sold 14 units. So that means that you ended up with 107 units of inventory in day number 2. What happened with Atlanta? Atlanta, today you sold 7 units. And you're going to ask me, why, Ricardo? You told me that my forecast, I have a maximum of 6. Here is my forecast. Why? The forecast is never mistaken, right? The forecast can never be mistaken. Is that true? That's not true. The forecast, it's always mistaken, okay? So in this case, the dice doesn't have 6 spaces. It has more than 6 spaces. How many? I don't know. That was the forecast that was given to me. So in day number 2, you sold 7. And we cannot punish the salespeople, right? Because they are pushing the company to succeed. So that's the reason why I cannot punish them. Okay, so in day number 2, you sold 7. You remain with a stock of 12, and you're waiting for these 15 units to arrive in the day number 5. Okay, what happened with Boston? Boston, you sold 6 units. That means that you remain with 11 units of inventory, and you're waiting these 10 units to arrive in the day number 4. Chicago, you sold only 1 unit. You have an inventory of 15 units, and you're waiting these 10 units to arrive by tomorrow. Dallas, you sold 2 units, and these 12 units arrived. So that means that your inventory is now 27. Los Angeles, you sold 2 units. You have 16 units of inventory, and you're waiting these 20 to arrive in the following days. Okay, let's see what happened day number 3. Let's go back to raw material. Okay, you are still expecting 160 to arrive in day number 5. In this case, in day number 3, you have an inventory of 100. Why? Because day number 3, the production only delivered 9 units. Why? You were producing 49 and 42. Why 9? Because we achieved the 100 cumulative production that the central warehouse suggested. Okay, they asked for 100. I deliver only 100, and now I have a lost capacity of 44. Now the people, these 13 people, they're not doing anything. Maybe they are playing soccer, or maybe they are doing something anywhere, but they are not producing anything because they don't have more demand. Okay, what happened with the central warehouse? The central warehouse, today you sold 17 units. That means that your final stock is now 90. What happened with Atlanta?
Oh my God! And we order only 100. We are in trouble.
That's one. Yes. Well, I don't know. Let's see later. What happened with Atlanta? Atlanta, you sold 2 units. You stay with 10 units of stock, and you're waiting for these 15 units to arrive in the day number 5. Boston, you sold 3 units. You remain with 8 units, and tomorrow you will receive 10 units of inventory. Okay. Chicago, you sold 2 units, but these 10 units arrived. So now you have 23 units of inventory in the day number 3. Dallas, you sold 1 unit, and you remain with 26 units of inventory. You are not expecting more inventory because your inventory has already arrived. And Los Angeles, what happened with Los Angeles? You sold 6 units. Now your stock is 10 units of inventory, and you're waiting these 20 to arrive in the following 2 days. Okay. Let's move to day number 5. Let's see what happened day number 5. Okay, so we simulated all the days. Now we're in day number 5. In day number 5, you arrive. The inventory has arrived. Now I have 160 more units of inventory plus the 100 that I kept. Now I have 260 units of inventory. Okay, the plant has a lot of lost capacity, guys. So it's really important, Vincent, Tani, and Abdallah, to think about this process, because now my capacity is down, okay? Because I have a lot of capacity. Today, in day number 3, you lost 44 units of capacity. In day number 4, 40 units, and day number 5, 46 units, okay? Central warehouse, what happened with central warehouse? We don't have lost sales. In these first 5 days, we didn't have lost sales. We're doing a good job. In day number 5, you sold 19 units. You had an initial stock of 73 and a final stock of 154. Okay, what happened with Atlanta? Atlanta, you didn't lose any sale. Really good job in here. Day number 5, you remain with 15 units for the following 5 days. Boston, you have 11 units remain. Chicago, 11 units as well. But see something, Chicago. In day number 4, your forecast was, well, your actual demand was 8. And remember, the maximum that you could sell daily was 6. That was your forecast. But once in this 4th day, you sold 8 units. Okay, so in day number 5, you remain with 11 units of inventory. Okay, Dallas as well, you remain with 15 units, and Los Angeles, 21 units of inventory. Okay, guys, before we get started, I think it's a really good moment to announce an important event that it's gonna be presenting the company. Okay, so the company was really happy because the salespeople were selling a lot. So the company set up a special offer to the company. So that means that we hired a new sales traveling man that is gonna be moving through Atlanta, Boston, Chicago, Dallas, and Los Angeles once a day. Okay, I don't know in which day. Maybe today it's gonna visit Atlanta, and tomorrow Boston, or maybe later to Chicago. I don't know. But this guy is gonna help us with sales. What would happen if this guy appears? Well, my forecast can increase because once a day, I don't know if he is gonna visit me in day number 1, in day number 2, 3, 4, or 5. But once a day, this guy is gonna visit me. And what would happen? For example, this guy and my ordinary salesman are gonna throw each 1 dice. So the minimum that they can sell in that day is 2 units, and the maximum is 12. So that means that my forecast changes. My minimum weekly is gonna be 6, and my maximum weekly is gonna be 36. The central warehouse and the raw material, remember, this is for the central warehouse and for the raw material and for the plant as well. Okay, now my minimum is 10 units per day and my maximum is 60 units per day. Weekly, if we talk about weeks, my minimum is gonna be 50 and my maximum is gonna be 300. Okay, so now my forecast has changed. And remember, the forecast is always accurate, so don't worry about it. I'm kidding, guys. So, okay, guys, I'm gonna activate the orders. And Zainab, can you please move everyone to the break rooms?
Sure.
Thank you very much.
Right.
Now, guys, we're gonna have 3 minutes to set an order, okay?
10 seconds.
10 minutes.
10 seconds to get assigned to the rooms.
Only 3 minutes for the next orders, guys. Okay, so I'm gonna share my screen now so that you can guys see what happened with Los Angeles, okay? If you wanna speak, you can raise your hand. If you wanna enable a conversation of how much inventory do I require in this moment, please let me know, okay? So you started with an inventory of 21 units, okay? I see that you have already set an order of 35. Are you guys agree with this? Can you raise the hand if you agree with 35 units of inventory right now? What do you think?
جماعة بعد إذنكم إحنا هنا في المين روم. إحنا كلنا ميوتد أوتوماتيك. اللي حابب يتكلم ممكن يريز هاند أو يعني اللي يوافق ريكارد دلوقتي على الأماونت اللي بيقولها برضو، يعني ممكن تريز هاند ديسكاس معاه عشان إحنا لازم نعمل أبروفال إن أنتوا تسبيك أو إن إحنا نشيل الميوت. مستر أيمن كنت حضرتك بتقول ما كنتش عارف تسبيك علشان ما كناش سامعينك، فاحنا لازم نديلك بس ابروفل من هنا.
هعمله.
Zainab, can we send a message to all the groups that there is 2 minutes remain?
Sure.
Thank you.
Oh, Mr. Ricardo, now I can't place an order. So we had to agree first. That's right. You only have the authority to place an order.
I'm sorry. What was the question again?
I tried to place an order, but I can't. I had an error. Yes.
Okay. Can you tell me the amount? Can I place it for you?
I can go for 30.
Okay. Do you want 30, right? Not 35. I see that there's an order.
No
okay.
issues. I agree with you. I agree with you for 35. No issues.
Okay, 35. So, okay, there you go. Perfect. Now, what are we gonna do? One more minute, Zainab, for everyone's to be back. So I'm now gonna stop sharing my screen since we have already agreed with the amount.
There's one message from Imam Farah.
Hello, guys.
No, from Abdullah. Ricardo, do you hear me?
Yes, I can.
Okay, there is a message from Abdullah Sanad. He said, guys, you have assigned me in the warehouse team, but in the game, I'm in the plant.
Okay, we will handle this.
Okay. Is someone in the plant? Who is in the plant? Because Vincent says that they don't answer. Okay.
Plant. We have 7 participants in the plant. We have Ibrahim, Merihan, Jason, Yuan, Pablo, Mr. Vincent, Muhammad Ghunim, and Muhammad Besha.
Okay. Okay, so you have enough participants, Vincent. Hopefully you get answers.
Yeah, I hope so.
Okay. So I think that I already have the people in the raw material. Well, they set up an order in the raw material, the plant as well. Central warehouse release an order, but then they cancel that order. Are you agree with that? I have too many people raising the hand. I also have Chicago with no order, Mohammed, and I also have Chicago with Atlanta with no order. Are you guys right with these amounts? I see Ayman and Samir are raising hands. Can we?
Ayman and Samir, you can unmute yourself, please. If you want to talk, please unmute your mic. Mr. Ayman and Mr. Samir.
Yes. Now I am not in the specific meeting room of central warehouse. Also, still I cannot get. There is one team decision, or everyone should decide how much the quantity he should order.
Okay. Can you give us some guess of the amount that you will require? For example, you have 15 units of stock already, okay, and you require more inventory for the following days, okay. So if you don't set an order right now, I think we're going to be in troubles, okay. So how about if we assign, for example, 30 units of inventory? That work for you, or the amount of units that you will require? Can you tell us some guess?
Mohammed, Mustafa, Ayman, who will give us the quantity, the order quantity?
Excuse me?
Yeah.
Yes.
Just I would like to ask a question. Now I am central warehouse at LA. When I try to place order, it doesn't show in the table.
Okay, how much?
For example,
Much
how
did
much
you
was
order?
that?
hello?
Yes.
Yeah, how much did you order?
For example, now the stock is 21 and I see there is order 30, but I didn't enter 30.
Yeah.
In the
Somebody
central warehouse? In the central warehouse, you we're talking about the central warehouse, right?
Yeah.
Okay.
Yes,
you
I
have
was in the
final state-
central warehouse. I was in the central warehouse, Ricky, and I was asking for the people to make the order. I asked to the local team if they agree with that. I suggested that amount, and no one answered. So because the time was running, I just ordered that. Okay, if they want to change it, it's up to the team. Okay.
Okay. Now I don't see any order placed. So if you have any requests, I can add it for you. Okay. So what would be the amount? What was the number one that you had placed? Can you hear me, guys?
I can hear you.
Okay.
Yeah.
Thank you. So for the central warehouse, can we limit the amount? Do you have any requests, Samir? If you don't, I can place the same amount that you that I saw at the beginning of the game. That was 300. Okay, so that we can continue with the game. Okay. So Atlanta didn't. Is that okay, guys? So Atlanta didn't release any order, and Chicago as well. Okay. So guys, I'm gonna deactivate the orders, and I'm gonna keep moving in the simulation. For example, day number 6. What happened in day number 6 for the raw material? So the raw material released an order of, in this case, of 200. But the supplier is still having a bad service level. The supplier is going to supply 180 units. So these 180 units, I'm going to be receiving them in the day number 5. So today, day number 6, the plant decided to fire 3 people. So in this case, the plant remains with 10 people only. So in this case, the plant threw the dices, and the total amount was 30 units in day number 6. So they are manufacturing 30 units. So in day number 6, the amount remained of inventory is 230 in the raw material, and we're expecting to have 180 more in the day number 10. So now the plant has a new order. In this case, 300 units. They need to manufacture 300 units. But in this case, the plant fired 3 more people. So now I think that we are in trouble because the amount that the central warehouse requires is bigger than the capacity that we already have. Okay. Now, what happened now? I remains with 230 units of stock. My real production in day number 6 was 30. That's my cumulative production in the day number 6. Okay. Now, what happened with the central warehouse? Today you sold 13 units. Okay, but in day number 5, you needed you delivered 91 units to the distribution centers. Why? Because Atlanta didn't release any order, Boston 50, Chicago 0, Dallas 11, and Los Angeles 30 units of inventory. Okay. Now, if you add all these orders, you have 91 units of inventory that must be distributed to the distribution centers. Your final stock right now is 63 units for your daily sale. So now in day number 6, you sold 13 units. So that means that your final stock in day number 6 is 50 units. Okay, that means that you remain with 50 units for the following days. Atlanta, what happened with Atlanta? Today, the salesman is you have two people. The sales traveling man visit you. Now remember that you ended up with 15 units. Today in day number 6, you guys sold 10 units of inventory. That means that you remains with 5 units of inventory at the end of day number 6. What happened with Boston? Boston, you have in day number 6, you only have one salesman. You sold 4 units. You have an inventory of 7 units, and you're expecting to have 50 units in day number 9. Chicago, what happened with Chicago? You sold 2 units. Now you have an inventory of 9, and you are not expecting to have any inventory, and the sales traveling man hasn't visited you yet. What happened with Dallas? Dallas, you sold 1 unit. You are expecting 11 units to arrive by tomorrow, and you now have 14 units of inventory. What happened with Los Angeles? Los Angeles, you have 18 units of stock, and you're expecting 30 units to arrive in day number 5. Let's see what happened up to day number 10. Let's see the final results in day number 10. So what happened with the raw material? Raw material, you received 180 units. This is the amount that you received, and you ended up with 276 units in day number 10. What happened with the plant? The plant, you had a cumulative production of 164, but the amount that was required was 300 units, and you could only produce 164. So that means that you couldn't deliver 136. So that means that you require more capacity for the next time. And what would you think human resources will react? So you decided to fire 3 people, and now you are thinking about hiring more people because you couldn't deliver that production? I think that we are in troubles right now. What happened with the central warehouse? Okay, we have a warning in day number 10. For example, we have lost sales in day number 10. We have 8 lost sales in day number 10. Why? Because we ran out of inventory. So my initial stock was 6, but I needed to deliver 14 units. I couldn't, so I missed 8 units of sales. Okay, I received only 164. My order was 300, but I only received 164. Why? Because the plant couldn't manufacture the 300 that I requested. Okay, so I start the following days with only 164 units of inventory. What happened with Atlanta? Atlanta, since you didn't release any order in day number 9 and in day number 10, you ran out of inventory. Okay, in day number 9, you lost 7 sales, and in day number 10, you lost 5 sales. What happened with Boston? Boston, in day number 7, 8, and 9, you lost sales, but you received in day number 10, the 50 units of inventory. But there is something important to mention. We received the inventory at the beginning of the day or at the end of the day. In most cases scenarios, we receive the inventory at the end of the day. So that means that in day number 9, we had sales, but we had an inventory because my inventory arrived at the end of the day. So in day number 10, I have inventory. I only sold 2 units. That means that my final stock in day number 10 was 49. What happened with Chicago? We also ran out of inventory in day number 8, 9, and 10, and I don't expect to have more inventory for the following days. So that means if I place an order right now in day number 10, I expect the following 3 days running out of inventory. Okay, because I don't have any inventory, any in-transit inventory. Okay, Dallas. What happened with Dallas? Dallas, you're doing a really good job. In this case, you have no lost sales. In day number 10, you ended up with 4 units of inventory. I think that we have a little inventory, and we will require much more inventory for the next days. And Los Angeles, you ended up with 30 units of inventory. In day number 2, you ran out of inventory because this amount, as well as in Atlanta and Boston, arrived at the end of the day, not at the beginning of the day. Okay, guys? So we're gonna do another 5 days, okay? I'm gonna activate the orders. You're gonna have also 3 minutes to place an order, okay, guys? But something important to mention, the sales traveling man is still moving around in the distribution network, okay? So he's gonna still selling for us, okay? So I'm gonna activate the orders, guys. I wish you luck, and you have 3 minutes to place an order, okay? So Zainab, can we send them back to the break rooms?
Done.
Okay. I'm gonna be with Los Angeles. Okay. Okay, guys, we have something important to mention is that day number 10, the sales traveling men visit our plant. Okay. So that means that in day number 10, we ran out of inventory. But now we start with an inventory of 30 units. Okay. So this is my initial inventory. And I will be requiring more inventory for the following 5 days. Okay. So the thing here is, what would be the amount that we will suggest to, as an order? Can you raise the hand if you want to participate, guys? Or do you think that 30 units is okay? Since Zainab, Juan Camilo isn't in the central warehouse?
I am in the central warehouse, but I don't know why I am not in there yet.
Okay. Can we reassign
Yes,
Juan
we will
Camilo?
reassign him.
Okay, thank you. And maybe can we change Vincent to the let me see which one is in trouble. I think to Chicago, Zainab. Can we switch Vincent to Chicago so that he can help the team? I'm just gonna help a little bit. Okay, Los Angeles already set an order. I think that there's no need to change Vincent anymore. I think that we just got covered here.
200.
Who should be in Chicago, sorry?
Who? Vincent?
Uh,
What was the question?
You need us to reallocate Vincent to Chicago?
No, it's okay. It's okay. I helped them out a little bit. I placed an order for them. So the plant, I think that they are struggling with the amount. Okay, they got 13 people as well. Central warehouse, they will require inventory 48. Okay, they are 0. Okay, can you send a message to the break rooms that there is 2 minutes left, please?
Sure.
Thank you very much. We're almost there. Those are the final 5 days of the simulation, and then we move to the demand-driven methodology. Okay.
Okay.
Okay, 1 more minute, and we call them back. Okay, the central warehouse already set an order. We can call them back.
We will close it now?
Yes,
Call them
please.
back? Call them back, yes, okay.
Yes.
We are back.
Yes, we're back. Can you see my screen now? Okay. If you can't see my screen now, okay. I'm gonna move up to day 15 to see what happened in these following 5 days. Okay. So for the raw material, what happened in the raw material? So they placed 250, but they only received 175. So these suppliers is still having a lot of variability, and it is affecting our processes. Okay. So the plant decided only to hire 2 people. Okay. What happened with it? The plant has a cumulative production of 180, and they couldn't deliver 220 units of inventory. Why? Because now the central warehouse is suffering a lot, and they decided to release 400 units of inventory. Okay, so the plant couldn't achieve 220 because they didn't have the capacity in this case. Okay. What happened with central warehouse? Now the central warehouse is in troubles because in day number 10, Atlanta released 35 units of inventory. Boston released 100 units of inventory. Chicago 35, Dallas 18, and Los Angeles 25. That means that they require 213 units of inventory. But there's something important to mention here. I didn't have 213 units of inventory, okay? I didn't have that much inventory. I could only release 35 to Atlanta, 51 to Boston, even though Boston suggested 100. Chicago 35, Dallas 18, and Los Angeles 25. Remember, in this conventional planning process, we use the first in, first out methodology to distribute the orders. And since Boston was the last one to place the order, Boston is the last one to release the order. So in this case, Boston was delivered only 51 units because we ran out of inventory in day 14. If we don't have inventory in the day 14, all the sales that we have in the day 10, 11, 12, 13, 14, and 15, we couldn't achieve, okay? So in this case...
Ricky, what happened with the order? We ordered 400. What the hell, what is happening there?
Okay, for example, in the plant didn't have that capacity, Juan. So you order 400, but in day number 15, you could only produce 180. Yes.
Oh my God! But what is happening there? They need to put more people there. We need more raw material. What is happening? Everyone. I have four salesmen, and we are having trouble with them. They are so sad because we have four. We need help with that plant and the purchasing department.
Exactly, Juan. Yes, we're struggling right now because raw material. They have bad service level in the suppliers. The plant is not hiring more people, and the distribution centers are requesting too much inventory because they suffer the variability as well. So we are in troubles in all the supply chain, not only in the central warehouse. Let's see what happened with Atlanta. Atlanta, you received the 35 units of inventory, but you ran out of inventory in many days. Why? Because you didn't have orders placed in the day number 9th, okay, you wasn't expecting to have inventory up to day 15. So now in day 15 you have inventory, but that inventory, you received that inventory at the end of the day. So that means that we couldn't achieve the sales of day number 15. Let's see what happened with Boston. Boston, you recovered, you didn't have lost sales, but in day 15 now you have 70 units of inventory. That's too much inventory for only one product. Okay, Chicago, you recover in day number 14, and now you ended up with an inventory of 28 units. Dallas, you have only one lost sales, but you recovered in day number 15. You only remain with only 1 unit of inventory. Okay, so in the following 5 days, I guess we're gonna be in troubles. So in day 15, for Los Angeles, we only have 1 lost sale. And in day 15, we remain with 33 units of inventory only. Okay, so now, guys, we're gonna move to the next phase. Okay, we're gonna be changing the parameters. We're gonna change all these scenarios, but by planning with the demand-driven methodology. Okay, so it's important, guys, to let you guys know that the methodology is a 20 hours methodology. Well, it's more than 20 hours methodology. So we're going to have only a brief review of what happened in our supply chain, and then we'll explain a little bit about the demand-driven methodology. And we run the 15 days of the demand-driven so that you can see the final results. Okay. So what happened with our supply chain? We suffer something called the bullwhip effect. Okay. And what is the bullwhip effect? It's an extreme change in the supply chain position upstream in a supply chain generated by some small changes in the demand. So we have some changes. Anything or every change that we have, it's going to affect us in the supply chain. So in this case, we have changes in the forecast, but also we have changes in the suppliers. So every single change that we have in the supply, it stresses everything out. Okay, so this is basically the bullwhip effect. What is demand-driven? Demand-driven is a disruptive methodology. It's a new methodology, a new model that plans and manage the supply chain to protect and promote the flow of relevant information and materials. What are the pillars of the methodology? We have the MRP, we have DRP, we have lean manufacturing, theory of constraints, Six Sigma, and innovation. So this is a full package of a big and complete methodology that is going to help us with the flow generation of our companies. Okay. The methodology has 5 simple steps. The first one, place the buffers. Okay, the methodology is going to help us to determine where to locate these buffers. And where should I locate the buffer? Well, in the demand-driven course, you're going to see 6 criteria of where to locate these protections. And these protections are going to help us to independize the supply chain, to help us absorb the variation of the demand and also the variability of the supply. Okay. The second step is to define the size of the buffer. Okay, in the demand-driven methodology, you see on a more detailed scenario of how to size the buffer. Okay, you're gonna see all the formulas to determine the correct amount of inventory. Then in the third step of the methodology, you have the dynamic adjustment. The buffers are dynamic. Okay, the buffers are not fixed, and we need them to adapt to the variability of the demand and adapt to the changes of the demand in order to survive to this VUCA world, this volatile, uncertain, complex, and ambiguous world. The fourth step, it's the demand planning. Once I define where to locate the buffers, the size of the buffer, and that the buffers are not fixed, they are dynamic, then I need to do what the buffers tell me to do. So the buffer has 3 colors, green, yellow, and red. If we're in green, we're not doing anything. If we're in yellow, we need to release an order. But if we are in red position, we are in extremely danger, okay? So my objective is never being in that red position, okay? Well, the first step is to locate the buffers. The buffers will absorb the variation. That's the main objective of the buffer, is to absorb any kind of variability in order to prevent us to some running out of inventories, okay? So this is my distribution network with buffers. I see that Atlanta, Boston, Chicago, Dallas, and Los Angeles, also the central warehouse and the raw material has buffers. I cannot buffer the people because people are operations. I buffer only the place where I can manage inventory. So that's the reason why Atlanta, Boston, Chicago, Dallas, Los Angeles, central warehouse, and the raw material has a buffer. The second step is to calculate the buffer. So the buffer has 3 colors. If the green zone determines the order and the frequency and the size of the order. The yellow zone is the primary coverage of the buffer, and the red zone is the safety part of the buffer. Okay, so here you have, guys, the formulas of how to calculate the buffer. So the green zone requires 3 calculations. We are going to take into consideration the minimum order quantity, the order frequency, and also a demand-driven calculation for the green zone to determine the size of the green zone, okay? The yellow zone, it's calculated by my average daily usage times the lead time, okay? In the demand-driven course, you will see in more detail these formulas in action, okay? And the red zone is going to help me out with the variation. So I'm going to add some variability factors to the red zone in order to protect me from the disruption and variation of demand. This red zone, it's not a safety stock. It seems to be like, but it isn't. The safety stock was designed not for being used, but the red zone of the buffer, it was designed for being used, okay? So I want to mention that in this part of the game, we have already done the math. In this case, you can see all the math applied to every single location. We have the buffer of Atlanta. We have all of the zones already calculated, as well as Boston, as well as Chicago, Dallas, and Los Angeles. And as you can see, all the buffers has different sizes. Why? Because the lead times are different. The average daily usage seems to be alike, 3.5 units per day. How do I calculate this 3.5? With the only information that was given to me, and was the forecast. I had an accurate forecast, but with that inaccurate forecast, I calculate my consumption, my daily consumption. I don't have that visibility of demand, okay? Remember that in this part of the game, we're going to simulate the same scenarios that we saw in the previous game, but now applying the demand-driven concepts, okay? The central warehouse, since the central warehouse has 9 salesmen at the beginning of the game, my average daily usage is going to be bigger. It's going to be higher. So that means that my buffer is going to be higher than these distribution centers, okay? Also, the raw material, since the raw material has the same average daily usage as the central warehouse, we're going to have similar buffers. As you can see, they're almost the same, okay? The buffers are not fixed. The buffers adapt to the changes. For example, we have an important announcement in day number 5. We have a sales traveling man that help us in the sales, okay? So that means that my buffers in the day number 5 should increase because my forecast increase. If the forecast or your actual demand increases, the buffers are going to be increasing automatically with the change of demand, okay? Now, step number 4, it's really easy in the step number 4. We're going to do an equation called the net flow equation. We need to understand what is coming, the in-transit inventory, what do I have, my physical inventory, and my immediately demand to determine in which position am I in the buffer. And it's a simple calculation. I just add my on hand plus everything that I have on order in transit minus the qualified demand, minus my current demand, okay? That gives me a position. If I'm in a yellow zone, okay, I need to place an order. How much? As much as you need in order to be in the top of the green zone, okay? So we're going to be simulating these 5 steps of the methodology, but now applying the demand-driven concepts. Now, there is no need, guys, for you to run these scenarios. I just want to do some example in here. For example, in the raw material, I'm going to do an example in the central warehouse and in all the distribution centers so that you can see how to calculate the net flow. And I will run the 15 days applying the same concept, and then we'll compare the results. For example, the raw material. I understand that I don't have actual visibility of demand, okay? I'm going to simulate the same scenario that I saw already. I have my buffer already calculated, okay? But I don't know in which position am I. How am I supposed to know if I'm in red, if I'm in yellow, or if I'm in a green zone position? Well, I need to calculate my net flow equation. And my net flow equation says, how much inventory do I have? 200. How many in-transit inventory do I have? 0. Okay, 200 plus 0, 200. How many demand do I have? 0. I don't see my demand. Okay, I don't have physical orders, so that means that my net flow equation is going to be 200. Okay, so 200, in which position place me? Am I in a red zone? No, because the top of red zone is 80. Am I in the yellow zone? Sure, because my top of yellow zone is 238, so I am in here, in the yellow zone. If I'm in yellow, that means that I need to place an order. How much do I need to place? As much as I need to get to the top of green. So if I'm in 200 and I need to achieve 396, that means that I need to place 196 units. As easy as that, okay? Before I get to the central warehouse, I'm gonna go to Atlanta. So in this case, Atlanta, you started with 20 units of inventory. You are not expecting any in-transit inventory because you are in day number 0. You cannot see the actual demand. So in this case, my net flow equation is 20. So in which position am I? I am not in a red zone because the top of red zone is 12, but I know that I'm in the yellow zone because I am in 20. So that means that I require another 28 units to be in the top of green zone. So I'm going to place the order 28, and there you go. Atlanta has an order of 28. Okay, let's go to Boston. Boston, you have 20 units of inventory. You are not expecting anything in transit, and you do not have visibility of current demand. You only have the forecast, but forecast is not the same as demand. It's a projection of the demand. So I don't have current visibility of demand. So that means that my net flow equation is 20. 20 is in the yellow zone as well. So I need only 30 units to be in, 23 units to be in the top of the green zone. Okay, because my top of green zone is 43. you can notice that all of the top of greens are different. Why? Because of the different parameters that we have, okay? For Chicago, my net flow equation is the same, 20. 20 means that I'm in the top of yellow and I require only 18 units to place. I'm gonna order only 18. Dallas, my net flow equation is 20, but 20 is still in the green zone. So that means that I'm not placing any order. As you can see, 0. Los Angeles, you are on a 20 net flow position. That means that you are in a yellow zone and you need as well another 28 units of orders. Now I place the 28 and I go back to the central warehouse. So I have the orders already placed. For Atlanta, 28, for Boston, 23, for Chicago, 18, for Dallas, 8, and for Los Angeles, 28. Okay? So what happening here? If I add all the orders, that means that I have 97 units of demand. Okay? I started with 200 units. I don't have any in-transit inventory. So that means that my initial stock was 200 minus the demand, that is 97, plus the in-transit, that is 0. That means that my net flow equation is 103. So 103 is actually in the yellow zone. So that means that I need to achieve 388 because I'm in the yellow zone. Remember, yellow zone means I need to release an order. Okay, if I'm in green, I don't need to do anything. If I'm in yellow, I need to place an order. How much? 285. That is the amount that I need to be in the top of the green zone. Okay, there you go. So let's see what happened. Let me go back to day number 1 and see what happened. Okay, I'm using demand-driven right now, guys, but it doesn't mean that the supplier is gonna release the proper amount of inventory on time and with the quantity that I suggested. Okay, it is demand-driven. It is not demand-driven magic. The supplier is still having problems with the service level because I release an order of 196, but the supplier released only 156. So I need to recalculate my net flow equation with these new units that I have, and I need to do the same scenarios that we did lately. Okay, so it doesn't mean that I'm using the demand-driven methodology. It doesn't mean that the forecast is going to be accurate. For example, in some case scenario, the forecast is going to be the same. I'm going to still selling 7 units or 8 units. I don't know. The forecast was mistaken. Okay, so let's see what happened if I move to day number 15. Let's move around with all the scenarios and see what happened with the methodology. As you can see, every time when I'm in the yellow zone, I release an order. If I'm in yellow, I need to place an order. If I'm in green, I don't place any order, as you can see. If I'm in yellow, I place an order. If I'm in green, I don't place anything, okay? And that's the way we're gonna be moving around. Let's see what happened with the central warehouse. In this case, the central warehouse didn't lose any sale. We had a perfect service level. And in this case, as we can see, we ended up with an inventory of, in the day number 15, with 173 units of inventory. What happened with Atlanta? Atlanta as well didn't lose any sale. The forecast was not accurate. As you can see in day number 2, I sold 7 units. In day number 9, I sold 7 units as well. And day number 15, as well, 7 units. So my forecast is not accurate as well. But I didn't lose any sales because I absorb the variability with this buffer and I move around with a better flow. Okay? What happened with Boston? Boston as well didn't lose any sale, but as well the forecast was mistaken sometimes. For example, day number 11, my forecast was 7. Okay? And also the sales traveling man was moving around the supply chain network. In day number 7, I have a visit of the sales traveling man as well as in day number 12. Chicago didn't lose any sale. Okay? In day number 4, they sold 8 as well. Remember, this scenario is a projection, is a simulation of the previous scenario. So we're simulating exactly what happened in the previous scenario. So in day number 4, remember, we had an inaccurate forecast, okay? In day number 8, a sales traveling man visit me, and in day number 13, the sales traveling visit me. So we could achieve the demand, absorbing the variability with the buffers. What happened with Dallas? Dallas didn't lose any sale as well, even though we have variability and disruption in the supply chain. And by the day number 15, we didn't lose any sale. In Los Angeles, by day number 15 as well, we didn't lose any sale. So now let's go to the comparison. What happened with both scenarios? In here, you're gonna see both scenarios, the conventional planning and the demand-driven planning, okay? What are we gonna evaluate? We're gonna evaluate lost sales, sales profit, service level, the stock, and also we're gonna evaluate the stock days, okay? So for example, in the demand-driven methodology, okay, let's see here, the service level. With the demand-driven methodology, we achieved 100% of service level. We did a really good job. In the conventional planning process, we only achieved 69% of service level. Okay. In some industries, the service is equal to the demand. If we don't have service, a good service level, we loses demand. So service level is always important in our operations. Okay. How about sales? In the demand-driven, we sold 572 units. In the conventional planning process, we only sold 397. How about the sales profit? With the demand-driven, we increases 44% the sales profit. We got 5,720 units of dollars, of profit, while in the conventional planning process, we only have $3,970 profit. Okay, loss penalty. With the demand driven, we didn't lose we didn't have any penalty, and with the conventional planning process, we have $875 penalty. And let's see the stock days. In the conventional planning process, we managed 29 days of inventory, but with the demand driven methodology, we only managed 27. Okay, so this means that we managed less days of inventory. We got a higher service level. My profit was higher. Okay, and also something important to mention, we didn't hire and fire more people. The entire game, we stay with the 13 people. This is the conventional planning process production. As you can see, the production seems to be low and then it seems to be higher enough. With the demand-driven methodology, the production was has symmetry. Okay, it was more balanced than in the conventional planning process. How about my inventories? My inventories in the conventional planning process were like a bimodal distribution. I had too many items in red, and also I was in the green, but in most case scenarios, I was running out of inventory. I was in trouble. But within the demand-driven methodology, the 70% of the cases, scenarios, I was in a green zone position, in my optimal level of inventory. In the workers, in the conventional planning process, you hire people and you fire people as well. In the demand-driven methodology, we kept the 13 people, and that's it. Okay. Well, guys, those were the results. I hope you enjoy the game, enjoy the simulation of the demand-driven. I know for the demand-driven, we require more time to explain the methodology, but this is a brief example of what the methodology can achieve. In this case, service level, inventory rotation, and synchronization in the supply chain. I don't know, Gustavo, Juan Camilo, do you want to conclude with some insights of the game?
No, it's just to say that the forecast is still used, but in a different matter, and that you analyze the buffers daily, but not necessarily you order daily, and that is a huge change there.
It's totally a game changer. Yes.
Yeah. I think maybe I would like to hear from some of the participants, how did they feel in the first part of the game when they use the traditional system, and then what the difference that they can see using DDMRP methodology. I don't know if someone wants to say something about it? All of them are good answers. Don't worry. Just want to let you. I just want to find out how did you feel during the game, and what the benefits you think there are, like moving to another different innovative planning tool. If you don't want to talk, you can chat. You can put it in the chat.
Or maybe you can raise a hand so that we can allow you to unlock your mic and you can participate.
No one wants to share their experience in the game?
Abdullah Senat has raised a hand. Can we unlock the mic for him, please?
Yes, guys. Can you hear me well?
Yeah.
Yes.
Yeah. First of all, I would like to thank you for this new model. At the beginning of the game, I was confused to place the order. Especially, I don't know if the requirement it will increase or it will decrease. But I see with your model, it is become good to give me like early alarm, especially for the color. So I believe it will be helpful. But I have another question actually. What if in your game, I believe it is simple model and it depends on short lead time. I would like to share with you my experience. I'm working as a planning specialist, trading items in material planning and as well production planning. In my case, the lead time for procuring the material is by 100 from 90 to 120 days as a supplier lead time. But for the selling lead time, customer lead time, it is only 14 days. So is it possible to apply the same principle to my case? Thank you.
Yeah, definitely. I think a lot of customers that we have the same configuration, like very long lead times for raw materials or for parts, and short tolerance time from the customer, that the customer wants their product very fast. And one of the things that Demand-Driven gives you is that possibility to have one thing that is called decoupling. So you can put buffers in the supply chain. Could be buffers, raw material buffers, could be intermediate product buffers, or it could be also finished product buffers that allows you to accomplish the customer lead time even when you have a long raw materials lead time. And we have plenty of customers that have just the same problem.
Clear so far, thank you.
I think obviously it's difficult to see in a very short period of time. We only had 2 hours, but there is a course that you can learn the whole methodology, and you will be explained how to manage all these type of products. Oh, Juan David Jimenez really enjoyed the game. It was very interactive, and you clearly see the difference between the results. If the conventional model was hard with just one product, can you imagine with more than like 100? We can see, we can say we have customers with more than 100, many more. We actually have implementations that we have to manage 900,000 buffers, and some stores that can have even 2 million buffers.
4 million.
Yeah. So yeah, you're right. Imagine if this was with one product, all the variability we experience, all the bullwhip effect. You can imagine it with many products trying to get the supply chain stable with no whip effect. This model really can do that.
Totally. And in all of our implementations, we can see the same results, okay? We see the same problem in all the supply chain. We always see that we have problems of service level, but also we have a lot of inventory when we don't need it, and too less inventory when we actually need it, okay? But with the demand-driven, we adapt to those changes. We break that by model distribution. We always push our inventories to be in these optimal levels of inventory. That helps us to react to this variability and VUCA world. Okay, so I think that the only way to prove this methodology is applying these concepts. Okay, so as Gustavo always says, first is the thoughtware, and then is the software. So it's important, guys, that if you want to try this new model, you need to take the demand-driven course, and also to prove it with the we can help you out with the implementation as well.
Yeah, the Symbios-Consulting team can provide help with do simulations, for example, to have a measurement of how your inventory has been behaving, and compare your inventory, but using the demand-driven methodology. And also there is a proof of concept project, which is a smaller project where you implement some of your products, and you can see how the products starts improving and the inventory starts getting balanced. No more stockouts and no more excess of inventory.
Yes.
And as you were very participant in the raw materials, how did you feel? Anas Sharaf, you there? Yep.
Yes.
Can you open up the microphone for Anas?
Yes. Really, I should appreciate this seminar. It was very creative. But I have a lot of things I need to mention, because I feel we are working as a separate departments. So the knowledge or the information was not passed between the departments. So everyone failed in his department, because we are considering from our mind what the other department, how he's thinking. So I have to increase the raw material. He have to fire some people. The sales, how he's going in the other warehouses. So this is the differences what we face in the location. But in the seminar, it's not. I cannot say it's not actually what we are doing in the actual life, because in the planning it's totally different what we are doing in the seminar here. Because once we are make order, we have to make a lead time of the suppliers, sometimes 45 days, 120. We have to make the not daily order, the direct to store. This is only for the small shops, but for big companies, I think we need to build like buffer stock for 45 days to sometimes 2 months, depending on the suppliers and the trading the companies. But I think there is some things we can add it in that production, and the programs can better for us.
Yeah, I think we have many customers that have the same problems that you have. Obviously, during the game, there was maybe some misconnection with some of the entities that were participating. But even when you're in a company that you have integrated systems and you share more information, even when that happens, you have the forecast. And obviously you start planning with the forecast because you have a long lead times, and then you have to start buying before the real demand comes. So when you do that, you are buying in a signal of demand that might be wrong because the forecast always has a gap versus the real demand. And it starts getting that bullwhip effect that we talked about. So with this type of methodology, you cannot, the variability is still going to be there, but this is a model that is designed to work with variability. Unfortunately, most of the traditional systems, they are not designed to handle variability correctly, and that will also impact the inventory levels. They will impact customer service, and we have many companies that have implemented this model, and they have had excellent results. And I'm talking about not only about small or medium companies, I'm talking also about very large companies that are implementing. We have implementations with the largest food producer in Colombia. We have implementations in Daimler, which is a huge automotive company. We have implementations with Grupo Mexico, which is the largest mining company in Mexico. So those are all companies of billions of dollars of sales per year, and they really were struggling with their supply chain, and they decided to change to this innovative model.
Okay, just I have one question. This model, if the plant will he produce one product and that's have many of ingredients, like a formula, bill of material, he can consider as a consume that item from the warehouse, the production to warehouse directly, or I will explain more. Like you have a forecast from the sales, so the production, he will make his planning depending on the forecast. So that plan will go direct to the supply chain or the inventory controller in the warehouse. So he will raise some orders to procurement department. He will make like stock in the warehouse. So the planning will start produce just in the system. If he need to produce one item, one SKU that have ingredients like 10 items, as example, so he will consume that all item in one push button with have some calculation of wastage.
Yeah, we have many. For example, we work a lot with food companies, and they have just the same type of design. Like they have a product that has many components, and so you have to design your supply chain, introducing buffers maybe in the distribution area. For all the distribution warehouses they have for their food, they have warehouse. They have buffers also in the central warehouse. They have buffers sometimes in intermediate products, because that intermediate product can be used to manufacture many of the finished products. And then we also generate buffers for the raw materials that are required to make these products on time. So there are four places where you can set the buffer, and one is the raw materials, the other one is the intermediate products, the other one is the finished products, and the other one is the distribution. If you have a distribution network, you can also have like in this game, different buffers for the same product, because it has different lead time, has different demand, and it has different variability. So yes, what you were asking, that if we can handle those products with many different raw materials, even some of those raw materials have a long lead time. Yes, we can do that in the methodology. It would take maybe a little time to explain, but we can do that.
Okay, that's great. So I think it's something interesting, because I will be honest with you, I work with Dynamic 365 and do that, and also in the SAP. In these two products, I use that module. Because I'm asking too much for this deeply in this questions. Yeah, I
Thank you.
appreciated that. Thank you, Habibi. Thank you.
Yeah, thank you. Someone else wants to participate, or if not, Juan, do you want to say something to close the game? Shireen, are you still connected?
Yes.
Yeah, go ahead, Juan.
No, I think it's okay, and that we are here to help you with any questions that you have, and with our great allies from the Middle East that we're going to continue posting with this, and we have really good videos that they are going to share with you about the methodology. Okay.
All right. Thank you very much for your time.
Thank you very much.
And I hope you like it.
Thank you.
Thank you,
Appreciate
everyone.
your time.
Thank you.
Thank you, everyone.